All right. 29th of April, 2025. This is Aiken PBL live coding, and we're going to do a live audit. Am I saying that right? Code Cow's been building. We took a first look at this. Now I wasn't ready. What's the name of the application is
Double spent.
Double Spend. There it is. Yeah,
Spent with a
let's
T.
take a look.
And yeah. Code Cow. Oh, I can. Yeah, Code Cow's going to share his screen, and I got it.
How are we on size? Do I need to zoom in on that?
Can you make it like a little bigger for us? Okay, perfect. Yep.
That's good.
Yep.
That's
Okay.
perfect. Yeah, that's really good.
All right. So this is, I'm sharing just yeah. Okay. So this window's just what's open source, which is just the Aiken contracts. It's not the whole dApp. Although we could get there someday. I'd like to, but
Nice.
all right. So here's the README. I don't know who needs to read this, but like I've told some people and they really don't like my idea. They think it's they don't like the Ponzinomics, they don't like the zero sum. And so I just, this is what it is. I'm not trying to hide. It's a zero sum game. It's less than zero sum. And we are changing theoretical Lagrange points of equilibrium, which is, it's all kind of theoretical. So I just want to put that out there.
I think that's a great. I think that just to pause on that, I do think it's good that you sort of when I explain it to people, it's an art is kind of art project like that works with those things, and you're on the upfront about it. It's basically to kind of how to own it and play with the fire or the snake or the sharp knife. It's just like, look, this is something that you're going to have to deal with. I get to use the kid analogy. It's just like, yeah, my uncle gave me a pocket knife, and he's like, you're probably going to cut yourself with this. You may have already done it playing with kids down the street, but now I'm going to give you one and show you like this is how you cut things. This is doing blah blah blah. It's like in my opinion, in that way, it's like a safety protocol.
Right.
Is that
What
what
you
you were
choose
thinking?
to do with it is your
Yeah,
decision. All I'm doing is showing you how it works, what it is, trying to, explain the code because
yeah.
ultimately it's just some validators, right? So like all these words that we try to say is just trying to communicate what the code is doing, but it's
Nice.
just coding. So, okay. So I followed Hinson's work, and I made these specifications. So these are all the validators right here. There's 7 of them. Marketplace is like it's a straight rip from Mesh. So we're not even going to go through that today because it's kind of a separate contract and it's just straight from them. So these are the other ones. And then I have these nice overviews. So if we come in here to contracts description, these are going to read, these are 7 validators. So I'll try to read it out loud. We have the Oracle NFT. This is the one-time minting policy, minting the NFT to be referenced token locking in Oracle Validator. It is used for serving static app information. So let's just, look at that. If we go into the specification, we can see the Oracle NFT has a parameter of UTXO ref, and the action is to mint with a redeemer. Right, it's just a one-time minting policy. And so here is
Hey, Code Cow, I have a small question. Can you explain what it means specifically about like serving the static app part? What does that mean?
what do you mean?
So
Yeah, where did you see that, Harsha?
right here, it is used for serving static app information. So what
Oh,
exactly
Yeah.
does that mean? Yeah.
yeah, I actually took that straight from Hinson, I think. I may word that differently. It's like the global state,
Okay.
right? Static app doesn't really make sense, but it is.
Oh, we're editing on the fly. Here we go.
Right. It's like it's the count, it's the fee address, it's all the game logic.
Mhm.
And all of this logic is stored on the metadata of the NFTs?
It's stored on the Oracle NFT datum.
Okay,
Ah,
okay.
okay.
Okay, so this is the Oracle NFT, which is just the one-time minting policy, so it's nothing special, but it gets locked at the Oracle validator, right? So on the left side, you can see the Oracle NFT is the one-time minting, and then that's going to get stored at the Oracle validator, and this has the all the game logic. So here we are expecting Oracle datum. We're expecting Oracle datum with all these, right? This is our game logic. So that's what that is talking about.
Got it, got it.
Right.
Okay.
Okay. Yeah, okay. This is I appreciate the question because I'm not exactly sure how to walk through this and like really explain it all. So yeah, that's the Oracle MT one-time minting. It gets locked to the Oracle validator. So let's hone in on the Oracle validator. Okay, so here's our datum. We have our count, treasury address, the pot address, fee address, winner, lock price, pot price, fee price, start price, slot increase. So this is it. This is the whole game logic right here. I put these updates just to kind of tell that like in the datum, count is going to change every single time we mint an NFT. And the winner changes every single time also. But all the other datums, these are static from the start of the game. So when you initiate the game, you set the lock price and all this, but it never changes throughout the game. Once it starts, it's set. And so that's what these static and updates are denoting, what's going to be changing. But the whole thing really works on this count. This increases every single time. So let's go into the action, right? The only action you can take is to mint. And I swear, it's like looking at the docs makes it more confusing sometimes. Right? Let's just look at the, yeah, this is the actual
So
validator.
trying to find the redeemer, the mint Plutus NFT redeemer.
Mm,
So the user mints a new NFT with the first contract, and then a UTXO is created at the second contract. Is that, am I getting that
yeah,
right?
yeah. So it's actually a setup procedure. But yes, so the admin to initiate the game mints the Oracle NFT, sends it to the Oracle validator, and then the game has started. So once that's at the validator address, then you can spend that to mint the first Plutus NFT.
Oh, so does the UTXO hold a bunch of NFTs? How does that work?
The Oracle is only concerned with one. The address could hold other policy IDs and stuff, but we check right, we parameterize our script, so we're only looking at that one. So the whole game is based off of spending one Oracle NFT every single time we're minting a Plutus NFT.
Oh, I see, I see.
Okay.
So let's just look at the Plutus NFT, right? Because this is the whole point. We're minting. These are the NFTs. These are the double spent NFTs where we can mint and we can burn these. And these are simple, but they work together with the other validators. So when we mint, all we're checking is that there is one input from the parameterized Oracle NFT policy, right? We use the inputs from our transaction and we use the param hash there, and we check that there is exactly one input. It has datum. That Oracle datum has the count. And then we create the asset name by converting the count into bytes. And then we check, is that minted? Only a minted token. We use the mint from our transaction. We use the policy ID from the mint, and then the asset name, which we just created based on the count. And so what we're saying is, if the count is 10, are we minting NFT named number 10? Or if the count is 50, are we minting NFT named number 50? So that's all this is checking here. But in order to mint this, we also need to spend the Oracle validator. Right, we also need to spend this to mint. And so here, this is really more of the bulk of the logic. This is a full Oracle datum, so we're expecting all of it to look like this. Here we're checking what do I want to say? Well, yeah, I mean, we could look at the pattern matching, but this is here's the logic right here, right? So is output value clean, which is making sure that the Oracle has a value of 2. And that just kind of ensures that it's this clean thing that we started with and nobody's added different values to it. Is count updated? This is checking all of the Oracle datum and making sure that everything that's static is the same, right? So pod address is static. So it's just making sure that it's the same. But then the count updates. So we make sure that that grows by 1. And then the winner also updates. And this can be whatever somebody wants. Like, they don't have to put a public key hash in there, but like, they're not, it would only hurt them if they don't.
Right.
And then, yeah, is fee paid? So this, right, there's 3 different fees. One goes to the treasury, one goes to the pot, and then one goes to me as the developer.
The fee, yeah.
Yeah. And so that's it. That's how you mint a new double spent NFT. You get the name from the count here, and you just make sure that that's minted, and you spend the Oracle, which makes sure that we're updating the Oracle by 1, we're changing the new winner, and then all these fees are paid. And that's how we mint.
Got it.
So this is the treasury. The treasury is in charge of the double spending of burning the NFT for unlocking 200 ADA. So the treasury is going to work with the Plutus NFT to burn. Right. So when we burn the NFT, all we're checking is that we're burning it. Check policy only burn. I think this is a cocktail function. Right. So that's how we burn it. But then we combine that with the treasury. Okay. And this is our treasury validator. We parameterize with the Oracle NFT and the Plutus NFT policy. And then I wanted to show you is burned. Right. So we're checking, is the token, is this asset name burned? Okay. And so where is this asset name coming from? Well, it's actually our redeemer. So that means a user could pass in whatever they want here. You know, it's not validated at all. So that we need to make sure that we're actually minting, or we're actually burning this. So that's what we do here. And then, and here's the trick is, okay, we check when our own input has some inputs. Okay. No, sorry. We want the asset name. Okay, so when Redeemer has the asset name, and then when we convert that asset name into a number, right? This converts the hex string back into an integer. So when that converts back to an integer, we get some NFT index, and this is the integer version of asset name. Okay, so here we're checking is asset name burned, and then here we're checking is the integer version of asset name less than count divided by 2. And that's that game logic, so we can ensure that only 49% are ever eligible to burn, is because we use the count and the asset name as an integer. Okay, I don't know if this is even useful.
Well,
Yeah.
no, I think it's useful.
Okay.
One, and I don't know if you want to get to this now, but one of those is how you use the testing. So part of the Aiken course, like right off the bat, like we do the testing, and I'm just seeing those trace statements, and I saw that you did all of the when I looked through the code, I was like, oh wow, he's using the testing. So maybe if when you're ready, like we could go through that. That would be something that would be pretty cool. And then I'm always mindful of the time. We've got like 30 minutes left in the meeting. We probably want to give like a little bit of time to check out and stuff. So you got headroom, so plenty of time to go into stuff.
Okay. Yeah. This is I don't know if I could like run the tests because I don't actually have Aiken set up here.
Oh.
I would just have to switch screens. But before we do that, let's just go through the last one, just so it can be out there, which is the pot. This is how you claim the prize pool. If you remember, the 4 ADA accumulates for each mint. That gets sent over to the pot. And this one I have recently, I did the withdraw zero trick, or I learned it. And so this one I it works. It's a little confusing to me. So here we have 2 validators that are going to work together. We have a pot spend and a pot withdraw. The spend, it's only going to check if our Anastasia design pattern, right? Aiken design pattern stake validator. This comes straight from Anastasia Labs, right? I copied this. And it's just these reusable functions to do this trick, right? This withdraw zero trick. So the only thing that this is checking is, are we using this hash, which is parameterized? Is there a withdraw script hash with a value of 0? So that's the only thing we're doing to check the spend. And the withdraw is actually going to check the game logic. So what's cool here, this is what I figured out, is like, why would you want this trick? Well, because I had this logic, that's all the game logic that's checking is key signed and valid after. And this was on the spending validator initially. It was here. And so what would happen is as you lock a 4 ADA UTXO here, and then you try to spend it, you're going to have to run that logic. But the transaction that we're actually going to be building is going to have a lot of these UTXOs, right? This is to drain the pot. So there could be hundreds of, or whatever, more than one UTXO here. So instead of validating the logic on all of those UTXOs, we do it once per transaction. And so it doesn't matter if we have 10 UTXOs or 100 UTXOs in the spend, we're only going to check is key signed once and is valid after once, which is pretty cool. Like once you understand it and like why you would need it. So yeah, that's what this is doing. And again, we're getting the Oracle datum. This is from a reference input. And we're checking the end of game, which is the start plus the count times the slot increase. And that gets our valid after. And then the winner comes from the datum, right? A lot of times I've seen the pattern where you pass in the winner or the who's supposed to sign with a redeemer or a datum or whatnot, but this is coming straight from the Oracle's datum, and just checking is it signed, and then that would withdraw. So yeah, those are it. That's the whole thing. I have a nice setup procedure. This is how I walk through and start the game. You know, yeah, I did this for me because it was just so confusing to like, how do you reset? How do you get a new one?
Right.
But yeah, this is it. So I have it all written down. The param dependency graph. This is what Hinson was talking about, right? We have our first layer. The Oracle NFT gets the UTXO ref. That's the one-time minting policy. Then we're going to take that Oracle NFT and throw it into the Plutus NFT, the pot withdraw, the treasury. And then the third layer, we use the Plutus NFT in the treasury and the pot withdraw in the pot spend. And then the marketplace, like I said, is kind of separate.
Right.
And then this is that main page, the user actions, which really describes the whole thing. So when we mint an NFT from the collection of Plutus NFT, we're doing validation of 2.1 and 3.1. Right. So maybe I won't read. I just kind of tired of reading out loud.
Yeah, man.
Right. But this describes all of the validation. So what I did was, you know, for 2.1, the Plutus NFT or whatever, right, you come here to the specification and then you just copy this and paste it here, right? And so that's what I did, is all these specifications for Oracle, for Plutus, for pot spend, for pot withdraw, for treasury, and for marketplace. I just aggregated those, and so it's easier to read here. And so this is the whole game logic of everything in one page. Okay, I need some water.
Thanks, Coattail. Yeah, this is pretty good. Yeah. I'm sure there's some questions.
So I have more of a question for everybody else here. What would you want to see? Like, obviously, there's some sufficient definition for an audit out there in the community, and that's wonderful. But like, what would it take for you to say, "Hey, I audited this, and I'm willing to like put my stamp of approval on it."
Well, we certainly need to run tests. We couldn't do it without running tests.
Good start. Good start. Yep. So we had a question about that. What else?
I guess seeing it work, you know, like I don't know. Like it is interesting to be like, oh, okay. Like trusting that things won't, you know, I like the idea of the split the pot like it's a donation. It's just like, okay, so there's not like there is a reward, but it's more of like, hey, I'm donating this as like a, you know, so it's not like you don't really expect things back. It's, you know what I mean? That sort of helps. Uh, um, but that might not be everyone's case. I don't know if you would play this game thinking you would win. I mean,
Well,
it's more like you're just trying to,
yeah. I
yeah.
mean, because it's a donation doesn't make me feel any less like I would want to be certain of its audit status, right?
Yeah, I guess because then you would say, well, I want to make sure that it does go to a winner,
Right.
right? Like you would like, you know, like
Yeah.
yeah.
If the prize pool was right, didn't go to the winner, or if the treasury didn't pay out 200 ADA to burn, I mean, you would want to know those before you entered, certainly. You'd want to trust it and verify it, because otherwise it is,
Right.
you just, I don't know.
Right. Well, it's just like bad, you know, I definitely don't have a a bad actor mindset, meaning that like I'm you know, like there are, you know, like doing like that type of testing, like try to break in, try to break it, you know. Remember the Harsha, remember that thing in CS50 with like try to break the AI prompts? And I was just
Yeah,
horrible
yeah.
at it. I was just horrible at it. I couldn't like try to get around the firewalls and try to like find the little cracks in the
No,
stuff.
it's just prompt injection, what you're talking about.
Yeah, yeah. But that mentality of like trying to get at the edge cases and try to like break things in the hacker. I wouldn't mind actually taking a hacker course so that you could learn how to, harden your applications. You kind of learn like what, you know, a bad actor might do
Oh
so
man,
that you could
you're speaking the professor,
thwart them.
which he would teach that course.
He would. Yes, he definitely brings that. He's definitely has that like we'll have to invite him. Code Cow, I hope that you'll come. I mean, like I would love to, yeah, to dig deeper in now that we've gotten a little bit and we could keep going with a wider audience. But Mix would
I do
definitely
have a
be.
specific question maybe we could talk about.
Hmm,
That I think is like we all, or like I need to understand better than I do now. So, um, the mesh open source code often uses the pattern of checking for one input to do something.
okay.
Um, and if you look at the Anastasia GitHub, they call that an anti-pattern, which I literally had to Google, which means a pattern that like introduces more vulnerabilities than like it solves. Um, and so they recommended tagging outputs, which I tried and failed. So I need to get back into it. I think I can probably get it eventually. But looking at my code here, I really base this off of Mesh's work. So I use that anti-pattern of the is there just one input here, thinking that satisfied the or it solved the double satisfaction. Okay, but like me not really understanding what the double satisfaction is or why it would solve it, I'm just kind of going with it. So here I'm checking, is there two? Right. So in Hinson's code, if this was just one, I would trust it. I would say, okay, there's when inputs at is only one, that means whatever Hinson said, and we can trust it. But for my validator, what I need is two. I need two inputs from the script. And so the question is, does this now introduce a double spend vulnerability? And kind of side step of that question is like, should I even be counting the inputs? Should I just, should I stop doing this pattern? And should I really try to figure out the output tagging and however the hell that works?
Good question. Um, can we look together at the Anastasia docs just to understand why they're describing it as an anti-pattern? I want to.
Yeah.
Yeah, and it's called. Yeah, this would be good. Like the double. Is there just one input as a pattern slash anti-pattern?
Yeah, just give me 1 second. I'm finding the GitHub.
Yeah, no worries. And the whole idea of the double spend problem, which is sort of fundamental to the whole like account model, UTXO model. Um, so this definitely gets us down into some good foundational mindset stuff.
Wait, I thought it was double satisfaction. Are they the same? Double spend and double satisfaction?
Double satisfaction is the vulnerability that we're talking about.
Right, right.
Correct. Okay.
Yeah. And then I stupidly or funnily named my app Double Spend because I don't know. Maybe that's just confusing.
Well, I love it. It's gadfly as heck. Because it sort of gets at that like, oh, there's a monster at the end of this book. Um, kind of vibe. It's very art, man. I really love it. I'm living in the Lower East Side, and there's all this like great like punk rock, like contrasty but friendly, culture um around. And so this, I don't know, this is I'm very interested, and I'm super stoked that you're here, and really glad that you're here, and sharing this and taking the time to go over it. And hopefully we're providing some value by being able to ask these questions, and get the learning. And then hopefully everybody builds little things or creates this this game, for whatever reason. I love the idea of the musical chairs or hot potato. Like that's the hot potato is a great one. Um,
So I'm looking at my screen. It seems like you're cut off a little bit. Oh, that's kind of annoying.
oh, oh.
Right? Can you not see all of that? Or
Fine.
can you see all of it?
Yeah, it looks good.
We can see
Okay,
it.
okay, sorry. It's just my phone that I'm looking at. So it's actually not from Anastasia, James. This is from the Aiken website, fundamentals/common design patterns. Here to prevent a vulnerability called double satisfaction, one must ensure that outputs associated with a given input are only counted once across all possible validations occurring in a transaction. The UTXO model, a common anti-pattern, is to predicate spending upon logic that is specific to a given input without ensuring the uniqueness of the corresponding output. Anti-pattern.
Bob
I
send.
don't want to read the whole thing, but it's on
Yeah.
it's on Aiken's website.
Bob is sending this to the validator with some datum. Alice does this. And then is there?
I can share more. I'll copy it over.
Yeah. All right, this is the description of what happens. Then they're saying, here's the example of what this looks like. And this sample code right here, this is showing you what to do instead. This is showing you how to handle the outputs.
It's actually much longer of
Okay.
a solution. It'd be better to look at their website.
Yeah.
I'll drop it in the chat.
Yeah, just
Harsha and I have definitely been spending quite a bit of time with this documentation. It's
it
right
just seems
below.
like something like we
Yeah.
need to like really understand. Like it's just fundamental to like how things work and how we need to be thinking about how to do things. This whole idea of output tagging is I don't know, right? It's just like I'm doing the is there only one input because I was told this is what you need to do without really understanding it. And so this is where it's like, okay, well now we need to do the better thing, but we still don't understand it.
Right. Okay. So this pattern is important when there will be multiple similar UTXOs locked at a validator address.
Mm-hmm. So like the pot would be a good one, or the treasury. Like both of these, I'm storing very similar UTXOs with the hope of spending them.
Right. Right. Yeah. And this is a great example, right? We want to be certain that somebody can't claim two UTXOs, and there is a yeah, there's every likelihood that somebody who can claim one UTXO might be able to claim a different one than that. And so we can't have a validator that would allow them to claim both.
Right. So when I hear that, that makes me think this line right here is a vulnerability.
Because all this is doing is saying, well, there's got to be two inputs from the validator, but we're not talking about the uniqueness
Yes.
there out.
Yes. Exactly.
Yep, exactly. All right. So yeah, you can use directly the solution they're suggesting here, tagged outputs.
Yeah. Yeah. It's just when I tried to implement it, it failed. Which is, it's just a problem with me. It's not. Right? I just need to figure it out.
Right.
Right. Because I guess I don't understand like what's tagging, like when you're actually building the transactions, what's tagging it.
Right.
But I mean, in terms of like this audit that we're trying to do, maybe this is a little side quest.
So,
But
so
right, I
your
mean, maybe not, because if we did just discover this line right here as a vulnerability, then
right.
well, then now it's the main quest.
Well, I mean, you already know. So forget about all of the logic they're showing here, right? They're saying here's a way to check. Let's generalize. They're saying here's a way to check the uniqueness of some output in some way. In this case, it has to do with the datum, right? But
Mm-hmm.
let's make it much simpler than that. You understand how to count the inputs to a transaction and use that in the validation logic.
Yes.
To start, just count the outputs. Are you counting outputs anywhere?
No, not here.
Yeah. So that would be don't try to implement the whole thing they have. Just if you're concerned, this is the treasury. Yeah, and of course, somebody should only be able to spend one UTXO at a time from this treasury. That is very clearly the logic of your app.
Well, no, it's actually two.
From the treasury.
The treasury, it pays out 200 ADA to burn the NFT.
Right.
And so that 200 ADA comes in the form of two UTXOs.
UTXOs. So there is somebody paying in, and who's there's some pub key hash trying to claim those two UTXOs. And there should never be more than one UTXO output to that pub key hash.
There should, correct. Yeah, yeah. And even with this, there can be two inputs, but there is only one output going to the transaction signer, right?
Where is it? Where do we insist there's only one output to signer?
Oh, that's not in the code yet. I'm just kind of walking with you because that is true. Like that is what we want.
So that's what we want. Yeah, because this
Yeah.
code right here, if I were to satisfy this logic, we can imagine the scenario, and we could probably design this test, right? There's there's a spending case here where I could spend four UTXOs at once and get two outputs. Oh, well, no, there's not. Well, yes, there is, right? Because you're validating because each
Well,
time,
with that wouldn't be a problem, would it?
uh,
As long as it's that ratio of 2 to 1.
right.
Right. But then like what are we even doing?
I mean,
What are we checking? And we're not checking anything.
you're saying, right, you're saying there has to be two inputs from the address. Okay, I'm going back to the Aiken example here. This says Bob.
Hey
Right.
guys, can you hear me?
Oh, there he
Yep,
is.
yep.
Hey,
I just get done of the public transport, so I can speak now. Yeah,
nice.
I think I jump in the middle, maybe I missed something, but I think the anti-pattern that Anastasia Lab mentioned is that you only take account into what's in the input, never think about what's in the output. But in general, I think we don't have to overthink those design pattern stuff. Just my advice would be just stay focused on what exactly you want to guard against. Usually, the mentality is we try to be as restrictive as we could. Just if you think about, for example, why you when you check the mesh contract example, I always use one input and one output. The kind of pattern is that I just want to have one simple tricks to make sure that the application is behaving like what I has expected. So generalize a bit into this scenario is that so far my understanding is that you want to make it like possible to unlock the multiple treasury outputs in treasury inputs in one transaction, but there's only one output restricted to one particular position, like for example, a dedicated script. So what you have to do is just make it very, very restrictive on the logics that you want to validate. Like for example, here, if somehow it's okay for you to pattern match two inputs, but you have to build the code yourself to take into account what's happening, what's exactly you want to check against when there is two inputs. So yeah, in general, is that we don't have to overthink. Okay, just think about what we want to check against it. Does that help?
I tend to agree with that. Yeah, I agree with that. And now I'm wondering, I think this might be I mean, if you look at the example again that the Aiken documentation is sharing, it's a fundamentally different example from this one.
Yeah, but then you will run into some issues if you are not unlocking one UTIX. So here is that, for example, you build a case of having two UTIX, so unlock it from treasury, and there's one output. The problem is that since it should be a spending validator, right? Yeah. Or is it the maintain?
This is spending.
Yeah. So if this is a spending validator and you want to unlock two inputs by the same time, the exact code will run twice.
Correct.
Yeah. Then you run into the execution unit issue very, very quickly if you're using this pattern. So if you try, whenever there's more than one input that you want to check against the spending validators in the same transaction, usually it's an anti-pattern.
The withdrawal zero track.
Yeah, you have to use something like withdraw zero or dedicate into it. Maintain,
so that's what we do with the pot, because of that exact reason you just said, is the treasury will only ever have two. So could we benefit from the withdrawal zero? Yes. But the pot could have many, many more than two UTXOs. So if either of those needs to switch, it's the pot. And so that's what I did with the pot, is I kept the treasury the same, super simple. This is going to run on every single one, but the pot uses the withdraw zero trick. And so the big logic gets run once, and the spending only checks for that script hash. Right.
Yep.
So I think good. Yeah. So in the treasury, what we're saying is, it's okay to keep this, checking for two inputs, because we really want that. But in addition, I should check that there is an out. I should count the outputs, right? And is that what we're saying? That's what I need to do. I need to count the outputs.
Yeah, I'm not 100% sure what's the business logic here yet, but usually the philosophy is we try to be as restrictive as it could be. Like if you didn't think about any kind of future interoperability, like those kind of elements. So you just think about what exactly you want the transaction to do, and prevent it from having any surprise from what you were expecting.
So I guess like the basic understanding is it is restrictive in the way that I want it to be. The double satisfaction is one of these things where I don't fully understand what I'm protecting against. And so it's hard to like say that I need to do this. Like, again, the reason I was doing this single input check is only because you were doing it. I haven't really grasped it yet. So, I think what I'm going to do is I'm going to try to check the inputs and try to become restrictive, or sorry, the outputs. I'm going to become more restrictive with the outputs in a way that makes sense. I'll look into that and try to see if it makes sense.
Sounds good.
Yeah.
I have a small question. So why are we not checking if the output is exactly giving out a value of exactly 200 ADA?
Yeah, right. I think that's yeah, right. That maybe that is exactly what we should be doing.
Yeah.
It's one of the things I thought was that like, okay, every line of code we write costs money, so like we want to write as little lines that we can.
Right.
And so if somebody could hurt the protocol, then we need to prevent that. But if they could only hurt themselves interacting with the protocol, then like I'm not going to prevent that in the code because it's just going to cost money. So if somebody puts in 2 UTXOs worth 10 ADA each, and you want to burn your NFT and take those 2 UTXOs, then like you could.
Yeah.
The code isn't going to prevent that because it's like it doesn't actually hurt the protocol. It like only hurts the user involved in it.
Yeah. Looking more closely, the example we are looking at right here is just not an example of this anti-pattern in the first place.
Cool.
Line 36, I mean, you see it very clearly here, and I agree with you as well about minimizing execution costs, right? We have to be certain that it's going to work, but like there is nothing like line 36 in the example they're sharing. And think about it. I mean, this validator will fail if there is any number of inputs other than exactly two from this validator address.
Mhm.
So any edge case, you've already limited the set of possibilities to that. Now, within that universe, is there an exploit? Maybe it's worth to check, right? But at least we know like this validator would not let somebody draw 3 or 4 or more UTXOs from the validator address. You're already there.
Mhm. Okay, cool. Yeah, okay, good. That was my initial line of thought, and then I've really kind of questioned it and questioned my understanding of it. So that's great to hear.
Oh, cool. Well, we're over time. I got to jump to another call, but this is exciting to be running through this, and thanks for showing up. Is there anything that we would hope to do with this next week?
I'm just open and excited to any help you guys offer.
Let's talk about it in the Gimbalabs Discord over the next few days.
Yeah.
All right.
Yeah.
Cool.
Thank you guys. Thank you so much. Really
Oh,
appreciate all your
thank you.
time.
All right.
Yeah.
Bye.
Beautiful. Bye, y'all.